Assalamualaikum and hello everyone. My name is Muhammad Razikhan bin Muhammad Ridwan. Today I am presenting on pipeline transportation in the United States. This evaluation covers how this vital network operates, its strategic advantages and disadvantages, the core regulations managing it, and a real-world case study on modern infrastructure vulnerabilities. To understand pipelines, we have to look at them as a specialized logistics network designed to move liquid, gases, and slurries over massive distances. They completely eliminate the need for physical vehicles or containers by using a continuous flow driven by pressure and pumps. Because the network is primarily buried, it minimizes surface disruption while providing an uninterrupted supply chain. Ultimately, this system is an absolute necessity for national energy security, shifting raw resources directly from major drilling basins to industrial hubs and consumers. Looking at the core characteristics of this transport mode, which is pipeline transportation, it is defined by three main attributes. First, it offers high reliability and low operational running costs over long timelines. Second, it is a completely fixed infrastructure, meaning its route cannot be easily altered once established. Third, it operates as a continuous flow system, functioning around the clock to maintain constant supply. From a strategic trade-off perspective, we have clear advantages and disadvantages of this mode of transport. The primary advantages are that it is incredibly cost efficient for bulk transport and it is automated nature, means there is a vastly reduced risk of human error. On the other side, the disadvantages of this transport are severe. It requires a massive upfront capital investment and it comes with continuous environmental risk and intense maintenance challenges across remote regions. For the infrastructure and networks of this mode of transport, we highlight two vital networks. First is the Colonial Pipeline, which stretches over 5,500 miles from Houston, Texas to the New York harbor. It served as the economic backbone for the US East Coast fuel supply, feeding major airports and metro hubs, and relies heavily on digital SCADA system for operation. Second is the Trans-Alaska Pipeline System, an 800-mile long crude oil pipeline cutting through some of the harshest frozen environments on Earth. For the policies and issues, because pipelines handles hazardous energy, they are strictly governed. Our regulatory framework is managed by FERC, the Federal Energy Regulatory Commission, and PHMSA, which is the Pipeline and Hazardous Materials Safety Administration. Underneath these regulations, the industry must constantly address systemic issues, specifically major safety concerns, leakage risk, and technical vulnerabilities that come with an aging infrastructure and the public demand for operational transparency. Two private enterprise giants act as the primary stakeholders dominating the American midstream landscape. Enterprise Products Partners, LP, is a midstream giant operating tens of thousands of miles of pipelines, acting as the primary connector moving crude oil, natural gas, and chemicals from drilling fields to to terminals. Meanwhile, Kinder Morgan operates the largest natural gas pipeline network in North America, functioning like a giant highway system for gas to deliver vital fuel to electricity power plants and local homes. For the case study of this mode of transport, we choose Colonial Pipeline cyber attack and shutdown. To see how stakeholders, policies, and challenges interact, we look at the Colonial Pipeline cyber attack. In this incident, a cyber attack compromised the company's administrative IT business networks. This forced operators to make the emergency decision to proactively shut down physical fuel flow to shield their automated SCADA engineering controls. This event exposed critical cybersecurity gaps and detection contingency gaps, proving that modern infrastructure safety is completely dependent on digital security. In summary, let's evaluate performance metrics. Pipelines achieve high efficiency because the system optimizes assets utility 24 hours without vehicle refueling or driver shift changes, and uses advanced internal coatings to minimize power use at compressor stations. They achieve high effectiveness by providing a highly stable, high capacity supply chain immune to severe weather, leaving a much smaller carbon footprint and diesel trucks. Moving forward, my core recommendations are to integrate advanced sensing technology to catch structural issues early and to enhance cyber physical regulatory oversight to protect our aging national grid. Thank you very much for your time. That is all from me.